here we are. This is going to be very brief. This is the end of Unit 4. I used to have more at this point, but I decided to cut some out. And I'm just going to present this little quick piece right here. So, obviously, we talked right now. Now we had 3 groups, and we proved some validity that there's some statistical significance between the groups, but we don't know if it's A, B, if the differences between group A and B and C, B and C, like we don't know where those differences are. So there are tests, obviously, to help us with that. And I'm just going to show you one of them. Okay, and then we'll make sure not to put any of the other ones in the exams. Okay, but the one we're going to use is called Tukey's Honestly Significant Difference, or Tukey's HSD, and it's what we call a Post Hoc test to see. And this is good when every group has the same number of people, right? So all the groups had 6 people. Obviously, that isn't always the case, and there's other tests, chef's tests and stuff that I used to include in the class, but I'm not going to now. And this is just so when we have the same number of people in each group, and we'll make sure that all the questions that we have and the worksheets only include that kind of group, okay? And so it's very simple again, right? So Q is equal to the square root of the mean of the square over N. And in this case, this was because I did a different one. So unfortunately, this doesn't line up with the problem I just showed you. It lines up with the one in the notes, but either way, it doesn't matter, right? So in this case, the mean of the square was different, right? Equal to, so the important part here is the mean of the square over N, which is the small n, the number of subjects in each group, which in this example was 5. Let's just work with that, okay? So the issue here is, you know what this is. You just did the whole test. You know that you needed to figure the mean square within groups is in your table. N, you know, right? So the unknown right at this point is Q, and we will find Q in the table, right? So we are going to look for Q, and we are going to figure this out. So let's see. I am going to show you the Q table. And basically what happens is we need to know the degree of freedom, which we do, right? The denominator degree of freedom, which was, what did we say? The within groups degree of freedom. So in this case, what I'm going to say is, I need to find my number. Right, so the within group freedom, and I need to go back to the table here to find out what that was. 12. All right, so, sorry. So, I'm going to use my table, right? So my degree of freedom was 12, and I had 3 treatments, right? It was 3 different groups. So if I have 3 groups, that means I did 3 different things, right? 1 to each group. Each group got a different treatment. Whatever that was. We can't say, like we study a lot of medications, we could, like one could get a placebo, one could get a certain dose, and another could get a bigger dose. We can show somebody, play somebody one clip from a movie, show the other group a different clip, show the third group a different clip, and we could ask them to tell us the story about the movie. Like whatever it is we're doing, each group got what we call a different treatment. Okay, so we have 12 and 3 treatments, and I don't know why I got this. at 3.77, right? So this is my value for Q right here. I got this from the table. The degree of freedom was 12. I have 3 treatments. And so when you come across, you'll see right there, right? 3.77. So all I did was plug that stuff in, right? Q times the square root of the mean of the squares divided by the number of people in each group, which in this case was 5. Then Q 3.77 times the square root of 0.88, which is 3.77 times 0.938, is 3.536. I rounded off to 3.4, right? 6, I rounded up to 4. And this is my critical value. So once again, what do I know? I already know my observed value was higher than that. In this case, for the ones that we used, this problem that we used this piece from, it was actually 6.09, right? Not the 10 that we had in the other problem, right? But in this case, it was 6.09. So once again, this just validates our critical difference, right? And it tells us. So this is what this means, right? Group A, Group B, right? We had, all right, I want to go back. All right, so now this is how we get our observed values for HSD, right? So we're not talking about our value of F. What we're looking for the post hoc test is the difference between the means. And so what we do is it's group A and group B, so that is the mean of A minus the mean of B, which in this case gives us 0.4. We want to know group A and group C, which is group A minus the mean of group A minus the mean of group B, which gives us 3.8 in this case. And then group B versus group C, right? Those are the 3 combinations where the differences could lie between the groups. We have the mean of B minus the mean of C. And so we have this. So these, in this case, are our observed values, right? And here's our critical value. So between group A and B at 0.4, we have no statistical significance, and we do not reject the null hypothesis, right? I know I jumped back, but I wanted to make sure, right? So here's our observed value for A versus B. For A versus C, this is our observed value, 3.8, which is greater than 3.5. So we do reject the null hypothesis, right? 3.8 bigger than 3.5. So for groups A versus C, we do reject the null hypothesis. Now for B and C, right, we have the observed value of 3.4, which is less than the 3.54, the critical value. And so we do not reject the null hypothesis. So what that means, now that I've said all that, is really the difference here is within groups A and C. That's where we find whatever the biggest difference between the means. That's where the difference between the means of those 2 groups had statistical significance. And there's none other between the interactions of the rest of the group. So I know that's a lot to process. It was a simple part and a quick part of the thing, but this is what you want to know, and this is the math you're going to want to know to get through the class, right? So hopefully, I know that's a little bit more confusing, and the theory mixing in with the actual math gets a little muddy, but like I said, please. If you're not getting it, just reach out to me or reach out to the tutors. I know some of you are working with the tutors. Some of you have been working with me, and I appreciate that. Like I said, I'm always happy. We get on Zoom and we review this stuff real quick. And sometimes I can make it it makes more sense on a one-to-one level. I can answer your questions directly. So feel free to reach out to me. But that's the end of Unit 4. That's the most, like I said, Unit 5, of course, still has math, but it's not near as complex and as challenging as these last 2 units. A little bit easier. So we're on the downhill side. If you made it this far, you're doing good. So don't give up. Like I said, reach out for help. That's that. We'll see you in Unit 5.